In this lecture, we're going to fix the camera so that it smoothly locks into place and has a better focus on the enemy when we start the lock-on process. We're able to lock onto the enemy, but the behavior isn't completely desirable. There are two problems with the way the camera works. Firstly, when we start locking onto the enemy, the camera immediately snaps into place, which feels weird. Instead of immediately snapping, it should smoothly move into place. The second problem is that we can't really see the target. The camera's position is a bit too low. That makes it hard to determine what the enemy is doing. How would we be able to dodge? So let's fix both issues. Starting with the camera's movement, open the player's blueprint file from the third-person/blueprints folder. From the component list, click on the camera boom component. This component is responsible for keeping the camera focused on the player. It's mainly used for third-person games like our combat game. One of the advantages of this component is being able to detect objects that block the player's view of themselves. If something gets in the way, the camera boom can move the camera to a better position. So it's almost like a spring arm. This component can force the camera to move smoothly whenever the player's orientation changes. In the details window, search for the keyword lag. There are going to be two options called Enable Camera Lag and Enable Camera Rotation Lag. These options tell the camera to slowly lag behind the player whenever they move around. Enabling both options will smoothen the camera movement, so let's enable both. You can adjust the speed by modifying the speed settings right below these checkboxes. The higher the value, the faster the camera moves. The lower the value, the slower it moves. In most cases, the default values work fine. Great, now let's work on the second problem. Search for a setting called Target Offset. The Target Offset option can be used to fine-tune the distance between the player and the camera. We're not going to modify this option through the editor. Instead, we should modify it while the player is locked onto their target. When the player is not locked on, we shouldn't bother adjusting the camera because the player should have complete control over where the camera is positioned. So let's open the declarations file for the lock-on component class. We're going to store the pointer to the camera boom component because we'll be using it multiple times throughout our class. So it'll be easier to store a pointer when the game starts. Inside the class's private section, define a variable called spring arm component. The type will be a pointer to the useSpringArm component class. Let's forward declare this class since we won't include it in this file. Alright, we've got our variable ready. Let's switch over to the C++ file. Initially, the variable is going to be empty, so we should take the time to set it from the beginPlay function. At the bottom of this function, let's set the springArm component variable to a function called OwnerReference find component by class. Throughout most of this course, we're going to be using this function to help us find components. As the name suggests, it'll find a component that has a specific class associated with it. Now you may be wondering, how do you know what class is attached to a component? Let's look at the components from Unreal. The class name is useSpringArm component, yet the component has been renamed to Camera Boom, so it feels misleading. To find the proper class name of a component, you can right-click on it. There's going to be an option to open a declaration file. Let's click on it. In Visual Studio, a file should open. This file is the class responsible for handling the logic of a component. We can find the class definition below the uClass macro. As you can see, the class name is useSpringArm component, so just be aware of this trick as you may need to create pointer variables to Unreal's components. Let's go back to our file. To grab a component by a specific class, let's pass it in as a generic to a function. Pass in the useSpringArm component class. Of course, this won't work just yet. We should include the declaration file to use this component's functions. Scroll to the top of the file. Include the game framework /springarm component.h file. Awesome. The last step is to adjust the offset. Scroll to the start a lock-on function. At the bottom of this function, we're going to update a variable called spring arm component target offset. The value for this variable must be a vector, so let's create a new f vector with the following coordinates: 0, 0, 0, 100.0. You can hover your mouse over this type for a description of each value. We must provide values for the x, y, and z axis. The only thing we're changing is the z axis. The z axis is the axis for the up and down direction. By using a positive value, we're telling the camera to move the camera slightly higher so that we can see the enemy. That should do it. Let's try compiling our game from Unreal. You will also need to compile and save the blueprint. Next, try playing it. Let's walk up to the enemy and focus on them. When we do, the camera smoothly rotates. Awesome. Everything is coming out great. However, I would prefer it if the camera tilted slightly downward, so let's quickly fix that too. Go back to the C++ file in Visual Studio. Scroll to the tick component function. As a reminder, we're using the find lookout rotation function to calculate the rotation. As we know, the z-axis is the axis for the up and down direction. If we want the camera to look downward, we can modify the target's location by lowering its value. By doing so, the camera is going to assume we want to look downward at the enemy instead of directly at them. Right before we create the new rotation variable, let's subtract from the target location.z variable by 125. Next, let's save our work and try recompiling our project. One more time, play the game and try locking onto the enemy. This time we have a much better view of our enemy. Perfect. That's exactly what we wanted. Our lock-on behavior is pretty much complete. In the next lecture, let's begin the process of ending this behavior, as we don't want the player to lock onto the enemy forever.